As I told you, our second order differential equation are important. When I want to write second order differential equation in general form, I write here 2 of x d2y by dx square plus a 1 of x dy by dx plus a 0 of x y is equal to f of x is second order linear differential equation with variable coefficients. If f of x is not equal to 0, is non-homogeneous, and if f of x is equal to 0, is homogeneous. An example I will give you, the Bessel equation is the example for that one. In Bessel equation, I just mentioned that we are having here the equation as x square y double dash plus xy dash plus lambda square y is equal to 0. This example of the second order linear differential equation, that's my Bessel equation. So mostly we are, as I mentioned, that we're having these equations. I can write here, this is 3 d2y by dx square plus 6 dy by dx plus 4y equal to 0 is my second order linear homogeneous differential equation with constant coefficients. Now, in general, we can write here a2 y double dash plus a1 y dash plus 0 y equal to 0. So the fundamental course of the differential equation we are mostly taking with the constant coefficients, and in higher course of differential equation we take the variable coefficient. With the variable coefficient, the things are not that simple, but we'll take some cases of the variable coefficient, but not the depth like Bessel equation, legendary equation, we get the result as a polynomial, but mostly we'll take the constant coefficient. Now this is a second order differential equation, the constant coefficient is a homogeneous one. When we want to find the complete, when we say the solution of this one, we say solution of this one will be having two constants y equal to c1 f1 plus c2 f2 will be its general solution. When we can write this solution in this form, when in a second order differential equation, when this f1, f2 are linearly independent. So that will be concept we will discuss. The question is, this is my general solution. If I want to find the particular solution, I need the value of C1 and C2. So value of C1, C2, I have two possibilities. I can use the initial conditions and I can use the boundary condition. Initial conditions are the condition at single point. For example, I take here the condition y at point A is equal to y1 and y dash at point A is equal to y2. Because these conditions are defined x equal to A, one point we say is initial conditions. Now if we are having the conditions defined at two different points, y at point A is equal to y1 and y at point B is equal to y2, or we are having y dash at point A is equal to y1, y dash at point B is equal to y2, or we can have here, or we having y at point A is equal to y1 or y dash at point B is equal to y2. These all conditions are known as boundary conditions. The boundary conditions are the conditions which are defined at two different points. In second or third order differential equation, we need three conditions. If I say defined at one point, we say these are the initial conditions. And when they are the third order differential can be defined at 2 points, it can be defined at 3 points. Anyhow, if more than one, we say they are boundary conditions. Now we are having two classes of problems. One class of problem is that we are having here the initial condition. We have the initial condition. We have the differential equation. And to get the complete solution, we have the initial condition. We call it as initial value problem. As I told you, the initial conditions are this number 1. Number 2, second case is we have differential equation and we have boundary condition. We say this condition as IC, initial condition, and this condition right here, we see the boundary condition. So this we call it as boundary value problem. Boundary value problem. So that's the main class of the problems in our differential equation: initial value problem and boundary value problem. Only thing is that initial condition means they are defined at one point. To find the particular solution, we need the condition. And if you define more than one point, then say the boundary condition. And differential equation plus boundary condition we call it as boundary value problem. So this is a very small definition of the initial value problem and boundary value problem. Inshallah, we're going to discuss the solution of the initial value problem and boundary value problem. The question is, there is one theorem that tells us that when we can say the solution exists. For example, I have this is my differential equation. I take a homogeneous one, and I want to see that I have the initial value problem. This is my second order differential equation, and I have the initial condition. We're having the y at point x0 is equal to y1, and y dash at point x0 is equal to y2 is initial value problem. Initial value problem. So the question is, when the solution exists and is unique. So the existence and uniqueness of the solution of initial value problem. So we have certain condition. The condition 1 is these coefficients a2 of x, a1 of x, a0 of x, and it is not homogeneous, and we're having here the function of x, then also this f of x are continuous on interval I. This is number 1. Number 2 is this a2 of x is not equal to 0 on interval I. Number 3, this point x equal to x0 is in the interval I. Whenever these 3 conditions are fulfilled, then we say that this is the problem we're having a unique solution. We say there is a unique solution for this problem when these conditions are fulfilled. So we can extend this one for third order differential equation, fourth order differential equation in a similar way. The important thing that we check, given any question, we check the coefficients, the continuity of the coefficients, then we see the interval we get that this coefficient, the first coefficient 2 of x is not equal to 0. Then we check the value, that's the condition at the point x0, that's in the interval.